All right, for today, we're going to talk about solving quadratic equations using the quadratic formula. But before we can do that, you're going to have to learn how to break down square roots, because we no longer want you to pick up your calculator and type in a square root and write down a decimal answer. Because you will notice, like down here, it says leave your answer in simplified radical form. Okay, radical is just a fancy word for a square root. Okay, so we got to talk about how can I break down square roots besides writing them as a decimals. So what we're going to do is we are going to start off with using a factor tree to help us break down the roots. Okay, for the factor tree, you can start by picking any number that goes into 150. So use your calculator, you can pick anything that goes into 150. I can tell you that if the number ends in 0, then that means it's always divisible by 10. So if it ends in 0, I would always personally just divide that number by 10. So if I took 150 and divided it by 10, then I would get 10 and 15. And then I would just go through and break each one of these numbers down. And so 10 would break down into 2 and 5. And 15 would break down into 5 and 3. And then 2 does not break down anymore, 5 does not break down anymore, and 3 does not break down anymore. So our factor tree is as far as it can go. Now, one thing you need to know about a square root is a square root doesn't put a little index number up here by the root. They expect you to know it, but the index number is a 2. They don't put it there because you call it a square root. So since you're calling it square, square means 2. So they expect you to know that the index number is 2. Now, why is that important? Why would that be important? The reason that's important is because once you make your factor tree, then you should be looking for pairs of the same number, because that's what your index number is. So it would take 2 of the same number to go on the outside of the root. So I always circle my pair numbers. So I'm going to circle my pair numbers. And then my single numbers I will put in a box, or leftover numbers, however you want to call it. 10 and 15, you cannot use 10 and 15 because 10 and 15 broke down. They are not on the end of a factor tree. Okay, so when you're looking at numbers to choose, they have to be on the end of the trees. Okay, so if you wanted to cross off 10 and 15 so you didn't get tempted to use those, you sure could. Okay, but remember, your pair number goes on the outside of the root, and your single number has to go on the inside. Okay, so I'm going to put 1, 5 on the outside for the pair. Inside the root, I'm going to put my singles, which are 2 and 3. Well, we don't want to just leave it as 2 and 3 because that kind of looks like the number 23, so that's not what we're going to do. But if you happen to have more than one single number, you are going to multiply them together. So then I would have 5, and then 2 times 3 is square root of 6. So then my final answer would be 5 square root of 6. Okay? So you just have to remember that your pair number goes on the outside, and you write your pair number only once. Okay, because the little index number is 2, so it would take 2 to write one of them on the outside. And then your single numbers will go on the inside. Okay, now the next 2 problems, the difference on these 2 is that you have a negative right here. So why does that make the problem different? Okay, so if I went to my calculator and I said square root of any negative number I wanted, my calculator will say error. It is not possible to get a real answer. It says, oh, in real mode, can't happen. Nope, 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 nope. Okay, so then we have something new to talk about here. So up here, we get to talk about what happens when we can't work it out with real numbers. Then that means we are going to switch to imaginary numbers. So for imaginary numbers, we are now going to have a notation for that, which means we are going to use the letter I. So whenever you have a negative underneath the root, you are automatically going to put an I on the outside with your pair numbers. Okay, so when I see this, if I have a negative on the outside, or I'm sorry, if I have a negative on the inside of the root, what I'm going to do is I'm going to be like, oh, well, I automatically get to put an I on the outside, and then that will turn my number on the inside into a positive. Okay, so I can get rid of the negative underneath the root by putting a negative on the by putting an I on the outside, which tells everybody that this is not going to be a real number answer, but an imaginary number answer. But then I can work it out just like it was a real number. So I can go ahead and do a factor tree for this. So I can pick any number I want. Okay, 432 is an even number. So then you can pick any even number you want that goes into 432. Now, hopefully you realize that when you're doing your assignment, we're not all going to pick the exact same numbers that go in there. I'm just going to go with 4. So 4 and 108. And then 4 is going to go down to 2 and 2. And then 108, I'm going to choose 4. So I'm going to go 4 and 27. And then 4 is going to go to 2 and 2. 27 is going to go to 3 and 9. And then 9 is going to go to 3 and 3. So remember, we're looking for 2 of the same number. So I have 2 2s, 2 2s, and then I have 2 3s. Okay, now, does it matter which 2 3s I circle? No, I could circle the 2 3s that are right next to each other. I could circle these 2 that I did, or I could circle these 2 right here. It doesn't matter. But like I said, you can cross off 4, 108, 4, 27, and 9 because they're all broke down. Leftover number is 3. So on the outside, I get to put a 2 for this group. I get to put another 2 for this group. And I get to put a 3 for this group. And then I have an I on the outside for that negative. And then on the inside, I only have a single number of 3. And then remember how we talked about over here, if I had more than one single number, I had to multiply them. Well, the same thing is going to run true if I have more than one group number. If you have more than one group number, go ahead and multiply them together. So 2 times 2 is 4, 4 times 3 is 12, 12 times I is 12I, and then square root of 3. Done. Okay, I would pause and try the last one by yourself. So whenever you're finished, here's my answer. Because there's a negative underneath, I have to put an I. I had a pair of 2s, so on the outside I have a 2I. And then my single numbers, I had a 3 and an 11, so 3 times 11 is 33. So now this row that we did here, this information is going to be embedded within the quadratic formula. Because you will notice when we look at the quadratic formula right here, the quadratic formula has a square root in it. So eventually we're going to have to break down numbers with a factor tree. Okay, so first thing you have to know is all of the equations need to be set up in this form. They need to look like this. ax squared plus bx plus c equals 0. So make sure all the terms are on the same side. A is always located in front of x squared. B is always located in front of x. And C is your plain number. And then here's the formula off to the side. The formula starts out with opposite B, or some people call it negative B, but that just means change the sign for B. And then we have plus or minus, and then square root, and then inside the square root we have b squared minus 4 times a times c, and the whole thing is over 2a. Now the one thing I will warn you about in the quadratic formula is right here. This b, when you square it, especially if it's a negative number, you have to put it in parentheses, because if you don't put it in parentheses, your calculator will give you the wrong answer. So right now, I would insert the parentheses just like I did right here in my purple, pinkish color, whatever. Put that in parentheses so that you will use it. Once again, when you're looking at the equations, you'll notice the highest exponent is 2, which means you should have 2 answers. So to ensure that we have 2 answers, we do have this plus or minus right here. And that means you will work it out once with a plus to get an answer, and then the second time with a minus to get your second answer. So you should have 2 answers for each one of these. All right, so let's get started. On the first one, does it equal 0? Are all the terms on the same side? And the answer is yes. Okay, so then let's make sure we can identify A, B, and C. Okay, so A is going to be in front of x squared, so that's 3. B is going to be in front of x, so that's negative 4. And C is your plain number, which is negative 9. And you're going to notice when I plug these in, I'm not plugging any variables in. I am only plugging in numbers. Okay, so the formula starts out opposite of B. So if B is currently negative 4, then that means I'm going to change it to positive 4. Plus or minus, square root, and then it's regular B. Remember to put that in parentheses. So I'm going to open my parentheses, put in regular B, which is negative 4 squared, minus 4 times A, which is 3, times C, which is negative 9. And then the whole thing is all over 2 times A. All right, now we're gonna get ready to use our calculator. And when we use our calculator, I am not going to type in the square roots. What I wanna do is whoops, hold on. I thought I changed the pink color. What I wanna do is I just wanna type this part right here into the calculator, not the square root, just that part. So I'm gonna switch over to my calculator now. So, okay. So what I'm going to do is I'm going to open my parentheses. I'm going to do negative 4, close my parentheses, squared, minus 4 times 3 times negative 9. And I got 124. So now I'm going to go back over here. and I have 4 plus or minus the square root of 124 all over 2 times 3, which 2 times 3 is 6. So now this is where I need to see, is 124 a perfect square, or is that something I gotta break down with a factor tree? So I'm gonna come to my calculator, I'm gonna test it. So if I do the square root of 124, if it's a perfect square, then my answer should be a whole number, not a decimal. And if I look at this one, I have a decimal. So that means 124 is not a perfect square. So that says to me, I have to do the factor tree. So then we need to pick any number we want that goes into 124. So I'm going to go with 4 and 31. And then 4 goes to 2 and 2. 31 does not break down. So I have a pair and single. So 4 plus or minus, I get to put a 2 on the outside. Oops. And then inside the square root is my single, which is 31, all over 6. Okay, before you circle this and say done, we have to check with all fractions and see if it reduces. And when we say reduce, we are looking at the numbers that are not inside the root. So we are looking at this information right here that kind of looks like a slice of pizza, kind of looks like a Dorito chip, but I kind of put these numbers right here together. These are the ones that are not under the root. So if I look at these numbers, are they all divisible by something? So 4, 2, and 6, you should all say yes, 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 yes. They are divisible by 2. So we're going to divide those by 2. So then we would come up with 2 plus or minus 1, square root of 31, all over 3. Now that's as far as I can go. I can't combine anything else together because I have the square root in the problem. So these are not considered like terms. So that's as far as I can go. But because there's a plus and a minus, that will count as 2 answers. Now, if you wanted to, you could separate them. So you could say 2 plus 1 square root of 31 over 3. And 2 minus 1 square root of 31 all over 3. So you could separate them out if you physically wanted to see the 2 answers. Or if you're okay with just leaving the plus or minus there, then you can do that. And you're done. So let's just go try some more. All right, so on the next one, does it equal 0? Yes. So a is in front of x squared. Is there a number typed in front of x squared? Nope. So if there's no number typed in front of x squared, you got to think of that as being the magic coefficient of 1. So a is 1, b is -9, and c is 27. So negative b, or opposite of b, will turn to 9. Plus or minus the square root, parentheses, regular b, which is -9 squared, minus 4 times a, which is 1, times c, which is 27, all over 2 times a, which is 1. Okay, then to the calculator we shall go. Oopsie. So now we're going to type in parentheses, -9, close my parentheses, squared, minus 4 times 1 times 27, and I get -27. Okay, don't type in the negative. because remember the negative means you're going to have an I because that's under the root, but I'm going to test 27 to see if it's a perfect square or not. Oh, and I got a decimal, so it's not a perfect square. So let's go back here. So I have 9 plus or minus the square root of negative 27 all over 2. That's not a perfect square, so I'm going to have to break it down with a factor tree. So I'm going to go 3 and 9, 3 and 3, and then I'm going to have a pair of 3s, single 3, so 9 plus or minus 3 on the outside, and because there was a negative, I have to put an I on the outside, and then square root of my single number, which is 3, all over 2. Okay, does this one reduce? So 9, 3, 2. Nothing goes into 9, 3, 2, so we are done. Okay, the next one gets a little bit trickier because you will notice it does not equal 0. So that's the first thing we have to do is make this one equal 0. So you want to move everything to where your x squared is. So I'm going to take the 17x and subtract it over. So I have 16x squared. And then if I take negative 23x plus 17x, that's going to give me negative 40x. And then I'm going to move my negative 25 by adding it. But when I get ready to add it over on the left side, are there any plain numbers over there? No. So I don't have anything to add it to, so I'm just going to put it behind the x because there are no other plain numbers to add it to. All right. So then my A is 16, my B is negative 40, and my C is 25. So let's go to town. So we're going to change it to positive 40 plus or minus the square root of negative 40 in parentheses squared minus 4 times 16 times 25 all over 2 times 16. Okay, calculator time. So we're going to go parentheses, negative 40, close my parentheses, squared, minus 4 times 16 times 25, and we get 0. Okay, if I do the square root of 0, we get 0. So this one is a perfect square. So since this one is a perfect square, let me catch up here. Hold on. Okay, so 40 plus or minus the square root of 0 over 2 times 16 is 32. The square root of 0 is 0. And since that's a perfect square, that means the square root is no longer there. So no square root because that was a perfect square. I didn't get a decimal on my calculator. Perfect square. Since there is no longer a square root, I need you to split the plus or minus. So you're going to go 40 plus 0 over 32 and 40 minus 0 over 32. Now, why did we split the plus or minus? Because these are all considered like terms now because there's no square root left in the problem. So 40 plus 0 over 32, if I get that, that's going to be 40 over 32. And 40 over 32 reduces down to 5 over 4. And then 40 minus 0 is 40 over 32. And that reduces down to 5 over 4. So this problem, I have 2 answers, and the 2 answers just happen to be the same thing. So moral of the story, if you get a 0 underneath the square root, you're always going to have the same answer twice. Okay, you should pause the video and try the last one by yourself. Okay, so I set up the quadratic formula. I got a 9 underneath my square root. 9 is a perfect square, which is 3. Because it's a perfect square, there is no square root left in the problem. Because there is no square root, you do have to split your plus or minus apart. So I split those apart and come up with 2 answers. And you should have 2 different answers because I didn't get a 0 underneath. So I got -5/2 and -4. Done.